Let's do this last video for domain and range, and I think you have enough information for you guys. Still believe, yeah, assignment number 5. Okay, logarithms. They're very similar to number 9. It does have an asymptote, but this time it's going to be that vertical. So a small reminder, since our start point is at -1 comma -2, which is right over here, we're going to have that asymptote at x equals -1. So just be careful. It looks like the graph is touching -1 at the x. It's not supposed to be. Okay, so with that in mind, let's do domain and range for this one here. Domain, not all your x values are going to be in, because it looks like it's just growing from the right side and there's nothing to the left of this asymptote. So your domain, x is greater than -1. Okay, it cannot be -1, but it can be more, 2, 4, 6, 8, and a little bit more. Okay, and let's write that in an interval notation. -1 is your lowest number, but it's not included. But everything can be higher than -1, and that's that. Okay. Your range, it looks like we're going to go low forever. Oh yeah, we're going to go low forever. I mean, over here is already -8, and then it's just going to go, to the negatives already. Will it grow more on the positive y values? And the answer is yes. It's going to be a very, very slow growth to go all the way up to, a value of 2 or a value of 3. Very, very similar to the slow growth for number 6 for your cubic function over here. It's going to eventually happen, but it's just going to take some time. So your range for this, all of your y values are good to go, and you are okay. Number 9 and 10, I do want to point out that 9 and 10, I don't know why this one over here, I finally just caught it, so I'm just going to put that x over here. If this was a base of 10 over here, then these two over here would be inverses of each other. What I mean by that, if you take a look at your domain and ranges, the domain is all real numbers, and then the range will be all real numbers, so they have that flip, okay? And then the restrictions come from the range for the exponentials, and the domains for the logarithms. 11, sine of x. Ooh, let's do some trig. Okay. So for sines and cosines, what AP usually do, what they do is they know for the trig functions, they're just going to go on forever. I mean, if you take a look at the cosecant, cotangents, for sine, it's an oscillating function. So what they've done for the most part is they've actually restricted, and so for 11, 12, and 13, let's restrict that. Let's restrict the boundaries from 0. So we're only looking from 0 to 2 pi. X and then 2 pi. Okay. And then normally they don't include the 2 pi just because, if we do 2 pi, it's going to be an equivalent of a 0 a little bit later when you plug in those values. Okay, so usually what AP does is they usually give you a boundary, a restriction. Give me the, what is the domain and range for just in between these two. So we're only looking from those, and so hence we can probably cut off the rest. Let's only look at from here to here, okay? Because we've already restricted our domain, that's going to be your domain, okay? Since we're only looking from 0 to 2 pi, that's going to be our domain. So let's go write that down. Our domain is 0 from 0 to 2 pi, okay? But not including 2 pi. Hence, when we do, so inequality notation, hence when we do interval notation, we are going to bound the 0 because we're going to, that's included with it. But when we go up to 2 pi, we're not going to include that. So that's going to be that parentheses over here. Okay. All right. Take a look at your range. It is also bounded between two values. Okay. And what are those two values? 0 and 2. And both are included because these are closed holes over here. So we can go 0 less than or equal to y less than, what did I say, 2? Yeah, 2. Okay. I actually kind of need to make sure that I put y's over here for the ranges. So let me just make sure that y, because sometimes I forget, like y, Y's. Okay, I'm safe so far. Okay, because that is your range, let's go write that. Very similar. It's just that this is not a 2 pi, this is a 2, and we're not. Oh, I did make a mistake. Good thing I caught it. Okay, we have to include the 2. Well, I'm not going to do any editing. That's just going to go on the video. Okay, so we have to include the 2, and apologies, this is a bracket over here, bracket. Okay, good thing I caught that early on, or else I would have to do some splicing. Okay, let's do number 12 and 13, and we're going to do very similar to to number 11. So when you guys are doing trig functions, just do it from 0 to 2 pi, 0 including. Okay, so that's going to be our thing for this. Okay, so when you guys are doing trig functions for this homework, for trig functions, just only do it from 0 to 2 pi, 0 included, 2 pi not included, okay? Because you just have that pattern, okay? Let's do cosecant of x. We know that there's going to be asymptotes for every pi, and so I'm just going to draw that. I didn't have to draw the negative pi because we're not even looking over there, but I'm just going to draw it. Okay, so now let's do tunnel vision. We're only looking at this part's over here, right over here. Okay, I've already restricted the where to look at, but if you notice, we're not including the 0 because there's an asymptote. We're not including the 2 pi because there's an asymptote. And on top of that, we're not including pi because there's an asymptote. So there has to be a way that we can write the domain so that we're not including those things. Okay, I think this is one way you could write the domain, and we're going to have to write it twice, and hopefully I have some room. I mean, there's 2 separate pieces to that. So it would be 0 pi, okay, so from 0 to pi and not including those, okay, and then or from pi to 2 pi, from pi x 2 pi. Oops, sorry, it's going on the other graph, okay, because we can input all these x values over here and it gives us a y value, but because there's asymptotes over here, we can't do 0, we can't do pi, we can't do 2 pi, okay. All right, even though I'm telling you guys to look from 0 to 2 pi, we can't even include the 0 for the cosecant. So make sure that there is no equal sign over here where the 0 is at, because there's that asymptote. Okay, so that's the domain, and then we can actually write that in interval notation. So this is inequality notation, interval notation. I like the in-betweens like this because you can just grab it and then bam, like that. Okay, then you have the parentheses. Remember, your or is your union, and then pi and 2 pi. Okay. All right, so for the domain, for the cosecant, if we're only looking between 0 and 2 pi, this is going to be your domain. Okay. Now let's take a look at your range. Again, tunnel vision, we're only looking in between these two. It looks like there are a couple starting points over here. So if you take a look at this part here, this is y equals 1, and everything is above that, and that's okay. And over here, this looks like y equals -1, and everything is below that. And there's no pieces of y values in between. So we're going to do another inequality where y is greater than or equal to 1. So that's this part over here. And then or y is less than or equal to -1. Okay. So or y is equal to less than or equal to -1, because this represents these values here. Okay, I wrote it like this, and so when we do interval notation, I'm going to have to write this one first because this is the least, the lesser of the amounts, and I'll put that on the left side, and then I'll do the or. Okay, so I'm just going to draw an arrow. -1 is our highest value, so it's going to be this, and then I have to be aware that we're including the -1, okay? And then or the union symbol, so this u over here, and then I'll put this in. So I'm trying to like put it in like numerical order, okay? The 1 is included, and then everything else can go above that. Okay, so that's going to be your interval notation for that. Okay, number 13. Cotangent, same thing. I'm going to just give you guys the restrictions. We're only looking from 0 to 2 pi. We're not looking at anything else. For cotangents, we do have asymptotes, and we do have asymptotes very similar to the cosecants, where we have asymptotes at pi. And the reason that they have same asymptotes is because if we want to remind ourselves what they were, remember cotangent is cosine over sine. Okay, and look, at the denominator is sine, and then cosecant is 1 over sine. So we have restrictions. Remember, we cannot divide by 0. So that's why they have the same asymptotes. They have the same asymptotes because sine is on the bottom. Okay, so that's why it's like, oh, okay, they have the same asymptotes, pi and 2 pi. Again, we're only looking in between these. Let's go tackle the domain and range for these. Okay. Domain. Well, the good thing about domain is I'm already telling you guys where to look at, and I believe we have the same domain as the cosecant. And the reason why we have the same domain as the cosecant is because we have the same asymptotes, and it looks like we can plug in all the x values are present over here in between these. So we're going to have the same domain actually, and I'm just going to copy that down. Okay, so cannot be 0, cannot be pi, but anything can be in between those, or this as well. Okay, cannot be pi, cannot be 2 pi, but it looks like anything can be there. And I'm just going to copy and paste what we wrote down at number 12. So 0, pi, union, remember unbounded, and then pi, 2 pi. This is a... Sorry, parentheses, and this is a comma. Apologies for that. Okay, so pi, comma, 2 pi. Okay, range. Your range is going to be a little bit different from the cosecant because of this added cosine on top. Okay, well, I mean, let's take a look at your range. Does it look like it's going to go forever up? Yes, it does. And does it look like it's going to go forever down? Yes, it does. And I don't think we have any restrictions for that. So just looking in between these two values, we're going to have a range of all real numbers, negative infinity and then infinity. Okay. You know, this video is taking a little bit too long just because we're almost done with the notes already. Let's do circles 14 and 15 and we are done for the notes for this lesson. Okay, domain and range. Okay. All right. Ooh, I like this one because we just look at the most left and the most right, and the most left is at -5 and the most right x value is 3. Okay. So -5 less than or equal to x less than or equal to 3. So those are your acceptable x values, and then we can plug in. If we plugged in 4, 6, or 8, it's not going to give us, it's not going to make this equation true. So it's only bounded in these. So -5 comma 3, and then with brackets because they're included. Range, let's look at your lowest y value. Your lowest y value is -3. And then your highest y value is 5. Whoops. Okay. So -3 comma 5 with brackets. Okay. All right. 15, last one. This is a little bit simpler than the trig functions. Okay. Last one. It's super similar. I mean, yes, we got that half circle, but your domain is between, and it's going to be included. Okay, these are closed dots over here. So from -3 to 7, I believe. So -3 less than x less than or equal to 7. Okay. And then we're going to just do that with the brackets. Range, be careful. Your lowest y value is -5. And then your highest y value is 0. So when you guys are doing the homework, so just a small reminder, when you guys are doing the trig functions like this, we might as well just write it down. So 36, 37, 38, and 39. Just really look at it from 0 to theta to 2 pi. Theta or x. Okay, so these are thetas over here. So you're going to have to use theta for your x for 36 and 37. 39, you guys can go back to x because this is an x. Okay, so for 36, 37, 38, 39, just only look at those. Okay, otherwise, you'll have to look at everything on the other functions. All right, you guys, that is it.